Hi everyone, today we are going to solve one of the induction problems. This is the past paper question from IB HL. So prove by mathematical induction that derivative of x squared ex is the same as x squared plus 2nx plus n times n minus 1 ex. Okay, for all integers, for positive integers. So we have three steps. I just highlighted. I don't want you to write this when you solve this question. Just I want to show you how we do it. And the first step, it is the basis step. It means I'm going to say that this is true for n equal to 1, and we will check left and right hand side. So for n equal to 1, let's see what happened. When n equal to 1, I'll just replace 1 into n. So in the left side, as you see, I don't have any n. Just write like the same. I have n here as a power. So instead of n, I'll just say 1, right? But you don't have to write 1 here. So in this case, we have n, which is 1, so it's also 1. In the right side, 1 times 1 minus 1 will be 0. Here, over there, which will be 0. And I'm going to check if the left-hand side is equal to right-hand side, the first step will be done. So let's check. Left side, I have derivative of x squared ex, so I'm going to use the product rule. What was the product rule? I'm going to take the derivative of the first term and multiply by the second, and now take the derivative of the second term, multiply by the first. So here, let's take the derivative. Let's take x squared. X squared is just written like this. Derivative of ex is ex, e power of x, plus derivative of x squared, which is 2x. That's here, times by ex. So this is my left-hand side. Right-hand side, I'll take the derivative of x squared. Here, I just need to replace n equal to 1. No need to take any derivative, right? Because we don't have a derivative in front of it. So x squared is the same x squared. 2 and x, so n is 1, so 2x. Instead of n, I'll put 1. So 1 times 1 minus 1, ex. So as you see, when you expand this, you get the same result. So the first step is done. Now in the next step, I'm going to assume that it's true all the time. It's true for n equal to k. So if it is k, if n equal to k, then all I have to do is to just change n with k. As you see, the powers here is n, so I'll change it with k. And here I have also n, so I'll just change it with k. So wherever I see n, I'm just going to replace k. So I'll put all this one in the right and the left. So instead of n, I have k minus 1 ex. Now, in the third step, we also want to show that this is also true when n equal to k plus 1. We can write this expression, or it's all up to you, but just want to show you that this is what I want to show. So what I want to show is this. In the right side, when I plug in n equal to k plus 1, I need to get x squared, which is x squared here. So instead of n, I'll put k plus 1, right, times by x. So here, instead of n, I have k plus 1, right? K plus 1 minus 1 will be k, just k, ex. You can just simplify this expression, this part. Will be 2. This is what I want to show. Okay, so let's try to find the expression for the left side. So I'm going to start with the left side and try to show that this right side is the same as left side. So now here, the tricky part is this. When you take the derivative of k plus 1, it is the same as d dx, okay, and the derivative of x squared e power of x. So, but from my assumption, I know that derivative of x squared ex is this one, right? So I'll just replace it here. That's it. Okay, this is the tricky part. So once you said k plus 1 dx power of k plus 1, it's the same as you take the derivative d dx one more time, and the derivative of the first part, the assumption part. Okay, I'll just replace this part here. Okay, now I need to take the derivative of inside. So we use the product rule again. What is the derivative of x squared? It is 2x. Derivative of 2kx will be 2x, 2k, and ex, because the derivative of k will be 0. It's a constant number. Now I'm going to take derivative of e power of x, which is e power of x. I'll put it outside. And the same expression without changing anything, I'll put it down here. Okay. Now, next step is to just expand the bracket. So as you see, once I expand, I'll get these expressions. Okay. But don't forget, the whole purpose is to show that the right-hand side will be this form. Okay. So I need to resemble left-hand side to the right-hand side using this expression. So how can we do that? Let's see. So if we put e power of x outside of the bracket, let's keep this here. Okay. So I have x squared. I need to have x squared. Yes, I have x squared, which is here. Okay. And then I need to factorize 2kx with 2x. Okay, which is here. Right. And then k with k squared, as you see, it's here. So now, as you see, the left-hand side will be equal to right-hand side if I factorize in this way. Look, there is no difference between them. So it is true for n equal to k, implies that this is also true for n equal to k plus 1. So it is true for all n element of power, positive integer. Okay.